I wanted to give you an example of how to set up and solve uh, a trig problem. First thing you want to do is label what they give you and what you are looking for. So X is what we're trying to find. They gave us this angle and they gave us this side. You have to know at least an angle and a side, or at least two sides to look for a missing angle. So on this one, we know a side and an angle, and that's enough. So we're looking for this side. So with respect to this angle, this is the opposite side, and this is the adjacent side. It doesn't matter about this side. Yes, it is the hypotenuse, and I can label it if I want to, but I'm not even going to use it when I set up my trig function. So opposite over adjacent. That reminds me of TOA. That trig function has opposite and adjacent in the ratio. So I know I'm about to use tan. So as soon as I figure out which trig function I'm going to use because of what they gave me, and it relates to the opposite and adjacent, which relates to tan, then I start setting up the equation. So it's tan of the angle. Always put the angle in this parenthesis right here. Equals, and then you do the trig ratio. Opposite is 2, adjacent is the x. Once I have this part set up, I don't want my calculator quite yet. I want to get rid of the fraction. So you can think of tan 35 as over 1. But when you cross multiply, the 1 times 2 stays 2, and x times tan 35 is x tan 35. So I just simply go and put that there. I want x by itself, so I need to divide this tan 35 off of this side and put it over here. So it's going to look like this, 2 over tan 35. Once I have this part set up, now I can type this into Desmos. So 2 over tan 35. So in my Desmos calculator, I'm going to type 2 over tan 35. Now, technically, if you want to put that in parentheses, you can. Notice how it's really not going to make a difference in my answer. One thing you want to make sure of in Desmos is that you are in degree mode. Okay, so the degree part is highlighted. If I change it to radians, look how the answers change over there. It does make a difference. So you always want to make sure that if you're doing trig functions in Desmos that you have checked to see that you're in degree mode. So my answer would be 2.856. Technically, you want to round to the nearest thousandth when you are working with trig problems. Well, I rounded to the nearest hundredth, so you would know that I would do opposite of what I should have done. I think on this paper I actually tell you to round to the nearest hundredth. Well, it was a worksheet at one time, but anyway, just do what this is doing, round to the nearest hundredth. I'm saying round to the nearest thousandth for future reference though. When you get into calculus, that's how they always want you to round. So we rounded 2.86. All right, so let's go here. The second slide where you're going to be doing all your work, you're only doing 4 problems. First of all, if you are having a hard time reading these angles, go up here to the spyglass and you can make it a lot larger. Okay, I could even make it bigger. I know it's blurry, but you can tell that's a 55. So you can slide up and see, slide. I don't know how I can slide over the, oh, here we go. Slide over, and you can see that's a 62. All right, I'm using the bar at the bottom to slide left and right. So I'm going to make that back to the 88, which is the normal. First thing I want you to do, so we're following these 3 sets of directions. With respect to the given angle, drag the words to the correct side for each triangle. So actually, I would not have to do trig on this problem because I noticed that it is a 45, 45, 90. So I could actually use my special right triangle rules. If you notice that, you have a choice. Do you want to use special right triangle rules or do you want to use your trig functions? But for this, I want you to go ahead and use trig. They're giving me this side, they're giving me this angle, and we're looking for that side. So this is my hypotenuse. With respect to this 45, that is the opposite. And I'm not even going to use adjacent. I could put it here, but no use in even using it because I want to focus on the two words that I need to figure out what kind of problem I have. So opposite and hypotenuse. You need to go to your notes and see which trig function has the words opposite and hypotenuse in it. And when you look, you're going to notice that sine has opposite and hypotenuse. So I want you to type the word sine here. And that's what you're doing in each one of these, and that's step 2. So you're dragging the words, so I've got them on all the sides. Then you're writing in which trig function you're going to use, and then you're going to set up your trig function. So you are going to grab a text box. You're always going to type your trig function first, in parentheses, put the degree, always, equals, and then we're going to do our ratio of opposite over hypotenuse. So I'm going to say x over 6. Okay, I know that's a weird symbol, so how can we do square root? Let's see, what could I do for a square root? I wish I could see a check mark. Well, you know, there might be something over here we can do. So insert, where are, I don't think special characters will work, but it might. Let me type square root. No, but what about a check mark? Oh, I just saw a square root. There it is, look. Cool. So, now what? Oh, there it is. I typed 2 of them accidentally. Okay, square root of 2. Now, I know that's ugly, so how could we do a fraction instead? We want to make that look a little bit better. I could go x and then enter, and then underneath the x, underline it. So go up here to the U to underline it, and then scoot this down underneath it. And I'm going to delete that slash. Okay, that's not perfect, but at least you can tell this is my ratio, x over 6 square root of 2. Okay, so set up the equation and then solve it. So remember, this is over 1. So I'm basically, if I can get this 6 square root of 2 over here to this side, which I can because I can cross multiply it, then x is going to be by itself. So my next level of work will be 6. So I got to insert that special character again. So special characters, I'm going to start typing square root, SQUA. Oh, there it is, look. Okay. So click it and get out, 2, and then sine of 45 equals x. So the next thing I'm going to do is to go type this whole thing, 6 square root of 2 sine 45 into Desmos. So 6 square root. Go down here to the keypad. It's right there. You can barely see it, but it's there. 2. And then I've already forgotten what I was supposed to write. Sine of 45. Make sure sine is not inside this. It needs to be on the outside. And look, it says 6. So 6 equals x. That makes so much sense because think about a 45, 45, 90. Remember how the legs, if I want to go from the hypotenuse to a leg, I would have to divide that by square root of 2. So 6 divided by square root of 2 would just be 6. Okay, so that makes sense. All right, so I've done this one for you. I hope you followed along. Now you need to go do 2, 3, and 4.